All right, we're going on to the next section, monomials and powers. We've been talking about combining like terms and adding and subtracting polynomials, but now we're going to talk about monomials and powers. And as we recall, and as you see here, a power is when you're raising something to an exponent. And so in section 13.3, we're going to talk about monomials, which we know is one expression or one term expressions, raising them to powers. I have a chart here. It's probably a good idea for you to copy this one down. In fact, I think you should, because in this little part of the exercise, you're going to be going through this and filling it out based on a couple of examples that you see. I think you're going to see a pattern that develops here that's really quite convenient for doing this monomial and power business. So if you want to go ahead and pause the video now so you can fill in this chart, I am going to go ahead and do a couple of them and then tell you to pause again, and then we'll go through the rest of them. Okay, so pause now if you want to copy this chart down. All right, if you're back from the pause, you have this chart copied down. You have these 6 different expressions with these 4 columns, and I'm going to show you exactly what goes in these. We're going to see exactly what this means. And so if we have an expression like 3x times 4x squared, when we expand that, we know that this is all multiplication. So it's really 3 times x times 4 times x, because x squared really just means 4 times x, that's 4x squared. And so if we regroup, when we regroup, we know that because of the commutative property, multiplication can be switched around. And so we're going to put things next to each other that go together. So I'm going to put these numbers together and use a separate color so that there's very little confusion. So this will be 3 times 4 times x times x times x. I've put the x's together and I've put the numbers together on purpose, because now I can simplify them, because 3 times x is just 3x, but 3 times 4, now that is 12. 4 times x squared is 4x squared, but x times x would really be x to the 3rd power. And so what you see developing here is a pattern where the exponents get added together. So we have 3 x's total, so that'll be x to the 3rd. And then we multiply the number parts together to give us exactly what we want. Okay, now in this next example, you can try these next 2. You can try these 2 on your own if you would like. So if you want to try that, go ahead and pause it. I'm going to do the 3rd one down and give you another example so that you can go ahead and do the rest of these. And so if we're thinking about excuse me, xy squared, xy to the 3rd, we're going to write what that means. Well, really that means x times y times x times y times x times y. Because xy is really x times y. And to the 3rd power means we're doing it 3 separate times. Once again, I'm going to regroup. And when I regroup, I'm going to end up putting all of my x's together. So I'll have x times x times x times y times y times y, which looks really long, and it looks really kind of complicated because we don't really know what x and y are. But when we simplify, we really get x to the 3rd times y to the 3rd. And so the simplification process is really just a matter of reorganizing it so it looks a little bit easier. If you would like to do these next 4 examples, pause right now. Do these 4 examples on your own. And I would suggest that the sub go ahead and pause this so that you can do these 4 examples. When we come back, I will do them and explain them. All right, so we're back. We're going to start at the top and write out exactly what this means. It's -2. Let me switch back colors so we're not getting confused here. We have -2 times x times 5 times 5 times x times x times x times x. Because there's 4 x's. X to the 4th is 4 x's in a row. When I reorganize this, I get -2 times 5 times x times x times x times x times x. I'm going over into this other box, but that's okay because I remember that when I simplify, I'm making it smaller. And so really this is going to be -10 times x to the 5th Notice once again, I'm adding these exponents. So I have x to the first power and x to the fourth power, which gives me x to the fifth power. Negative 2 times 5 is negative 10. Down here, negative 3x times negative 3x times negative 3x. Well, really that's negative 3 times x, negative 3 times x, negative 3 times x. And so when I reorganize this, I have negative 3 times negative 3 times negative 3. And then I've got times x times x times x. And negative 3 times negative 3 times negative 3 is going to be 27, and it's going to be negative, so it's negative 27. Switching colors once again. Negative 27 times x to the third power. Coming down to the next one. Hopefully you got this. 5 times x times 2 times x times x times x. You're probably wondering, well, isn't 2x to the third 2x times 2x times 2x? Look, the 3 only goes with the x. Up here it went with the whole thing, but down here it only goes with the x. And so if it's only by the x and it's not outside the parentheses, only the x gets multiplied 3 times together. So when I reorganize, I really end up with something that looks like this. 5 times 2 times x times x times x times x. Notice, x to the first, x to the third gives me x to the fourth. 5 times 2 is 10 once again. Okay? Down here at the bottom, notice we're on the outside of the parentheses now. And so it's the whole thing raised to the second power. So I've got 3 times p times q, which is what 3pq actually means, times 3 times p times q. And so that's a case where we're squaring the whole thing because it's outside the parentheses. We're telling, this exponent tells us, take the whole thing and multiply it by itself, as opposed to when it's just by the x and it's saying just take the x and multiply it by itself. Okay, so we've got this. When we reorganize, we've got something in red here, 3 times p times p times q times q. And that gives us 9p squared q squared. The good news is you don't always have to expand it like this, because if you're taking your time to expand it like this, you should be noticing a pattern. The pattern develops that you're simply adding the exponents. And so down here at the bottom, when we had this 3p squared q squared, we just put the 2 along with each part of the thing that we were multiplying. And so when we go on to the next slide, you're going to be able to do this without expanding. You don't need to show your work necessarily, unless you feel comfortable doing it this way. This is a fail-safe method. But if you're comfortable doing it while you're just adding the exponents, that's fine. Here's example 1. I'm going to go through the first one with you, and the second one, through the fourth one, through the fifth one, you are on your own. I'm going to expand it just so you see what's going on. This would be 2 times x times x times x times negative 3 times x, which would be 2 times a negative 3 times x times x times x times x. And once again, if I add the exponents, I've got negative 6x to the fourth. That's my answer here. Okay? Notice, I added the exponents of the x. I've got 4 total x's. I've got negative 6 from the 2 times 3. If you would like to, go ahead and pause this right now. I would suggest your substitute pause this. And so you can do the next 4 examples on your own. And when we come back, I will do them. We'll go step by step. We might even do a little shortcut on the last one. All right, so go ahead and pause it right now. We are back from the pause. If we're back from the pause, that means that you probably have all these already done. And if you didn't show your work, that's okay. Because if you didn't show your work, that means you're starting to understand that you're adding these exponents. And so if you put 4 times a times a times a, and you got 4a to the third, great. If you just added the exponents and you said that that's 4a to the third, great. This is a shortcut. Down at the bottom here, I've got negative 2 times 7, which would be negative 14. And m times m squared would be m to the third. So I get negative 14m to the third power. It should be getting easier for you. You should be able to start visualizing this. In letter D, we have a negative number. So that's really equal to negative 1 times x times 8x squared. And so negative 1 times 8 would be negative 8. X times x squared would be x to the third. And there we are. I'm using those little arrows and those little lines to try to say these are the two things we're multiplying together. Down here, we have 5. We have y to the 8th. There's the shortcut. There's no work necessary. You're adding the exponents, understanding that y to the 5th is 5 y's in a row, and y to the 3rd is 3 y's in a row. So if you line them all up, you have 8 y's in a row. You put the number in front. Okay? Example 2. It's more of the same, except now we have a monomial times a binomial, but we remember, of course, that when we multiply something by something in parentheses, the order of operations has to come out. And so, as we've talked about in the past, our order of operations is dictating that we do a little bit of multiplication this way. And so we end up with two separate problems. I'm going to write in green. 2n times 4n squared minus 2n times 5. Those are my two problems right there, represented by the two arrows. And so really it's a matter of multiplying monomials, not necessarily binomials. And so I've got 8n to the third minus 10n. I'm going to do likewise on these last ones. Go ahead and pause it right here if you think you need to. The substitute can pause it and you will go ahead and go through these, and then when we come back, I will wrap this up for us. We are back from the pause. So we've got 2p squared plus 3p. Down here, a little bit trickier, but we'll end up with a positive 2t to the third plus a negative 8t squared. Okay? Up here, we're going to have 5 to the third, y to the third, z to the third, which is 125, y to the third, z to the third. Down here, because we're squaring a negative, it's going to be positive x squared, y squared, because we've really got negative 1 times negative 1, which we know is a positive 1, x squared, y squared, which can be written as x squared, y squared. Your homework assignment will be given to you. This is multiplying monomials. It's really a matter of adding the exponents. So good luck with your homework.